Got it. Hello. Yeah. Myself Dr. Lokesh Kumar Bansal, and today I'm going to deliver a lecture on analog communication system. So just we start communication. What is the communication? Communication is the transmission of information from source to the destination through a channel or medium. It may be in the form of speech, gestures, graphical symbols, images, videos, etc. The basic elements of communication systems are the transmitter, channel, or medium, and the receiver. Now, again, if we'll see, then the information will be collected from the source, then it is converted into electrical signal through the transducer, then that electrical waveform transmitted by the transmitter to the receiver through the channel or medium. Again, here the channel or medium may be the optical fiber, copper wire, free space, anything. And then the received signal is again applied to the output transducer, and then it is applied to the destination or receiver. So the basic elements of communication systems are the information source, transmitter, communication channel, receiver, and destination. Or so here we can see the voice signal is first converted into a electrical signal through mic. Then that electrical signal is processed electronically, then it is transmitted by the transmitter into converting into the electromagnetic waveform. Here the function of the transmitter is to amplify and modulate the signal, and then that electromagnetic signals or waveform transmitted to the receiver through the channel. Here some noise are introduced by the channel. That noise is also called the external noise. Then that electrical signal is received at the receiver is applied to the transducer. Your transducer may be a loudspeaker or the printer, anything. Then the electrical signal converted into the again voice by the loudspeaker or speaker. So we can say here the information source. It is the source that originates the message or information which is to be communicated. It may be a human voice, picture, code, data, word, group of words, music, symbols, signals, videos, etc. And the transmitter that we have already seen or discussed, transmitter is the combination of the transducer, amplifier, modulator, oscillator, power amplifier, and antenna. The function of the transmitter is to collect the incoming message signals from the source and modify it in a suitable fashion such that it can be transmitted by a selected channels or medium to the receiving end. Channel, as we discussed, channel is the physical medium that connects transmitter with the receiver. It may be in the form of copper wire, coaxial cables, fiber optics, or free space. Receiver is just reverse of the transmitter. It is a combination of the antenna, amplifier, demodulator, oscillator, power amplifier, and transducer. The function of the receiver is just to receive the modified message signal from the channel and process it into to generate the original message signal. Noise. Noise is the unwanted or undesired electrical waveform that corrupt the message signals. Noise can be classified into two broad categories depending upon its source. Noise generated by the components within the communication system, it is referred as an internal noise. And another one that is called the secondary noise, that is the noise called external noise, that is due to the sources external to the communication system, that may be either environment or that may be due to the channel. The mode of communications can be divided into three types: simplex system, half duplex, and full duplex system. In simplex system, it is the system capable for sending the information in one direction only, where the sender can only send the information and the recipient can only receive the information. For example, it may be TV or radio broadcasting, FM. Again, signal is sent from one channel only to the receiver. Another one is called half duplex system. In half duplex system, again we will use one channel, but either it may be used for either transmission or the reception. So it is the system capable to carry the information in both the direction, but only one direction is allowed at one time. For example, walkie-talkie that is used by the railways, or it is used by the event management, or it is also used by some police departments or in forest departments. So this is the another example. Another next one is the full duplex system. Full duplex it is the system that can be carried both directions simultaneously. For example, it means a mobile phone system or telephone system. Here the two channels are used separately. One is for sending the data and another channel is used for the receiving the data. Now, again, based on the type of the modulation schemes used, the nature of the output of the information source, communication system divided into three categories, that is analog communication system, digital communication system, and hybrid communication systems or hybrid system. In analog communication system, that is designed to transmit the analog information using analog modulation method. Here, whole system will be analog. In digital communication system, here it is designed for transmitting digital information using digital modulation scheme by the digital hardware or digital system. So that is another one. Now, next third one is the hybrid system. Hybrid, that is the combination of the analog as well as digital communication system. So in this hybrid communication system, that use the digital modulation scheme for transmitting sampled and quantized values of analog message signal. For example, here we can take our mobile phone, that is the real example of the hybrid system. And we can take suppose the communication between CPU and pen drive, that may be the example of digital communication system. And here we can say simple AM or FM, that may be the example of the analog communication systems. Now, what is the signal? Signal is a set of information or data that can be mathematically represented or described. The signal is a function of one or more independent variables. Any detectable energy that carries some information, that is called signal, and it conveys the information. For example, it includes speech signals or telephone or television signals. Here the signal is a function of time. The signal in which both amplitude and time vary is called continuously, is called analog signal. For example, the speech, television signal, etc. So this is the simple analog analog signals. Here the both amplitude and time are continuous. So this type of signals will be used in an analog communication system, analog system. So what is the system? System is an entity that processes a set of signals or input to yield another set of signals or output. A system may be made up by a physical components, as in electrical or mechanical system for hardware realization, or it may be an algorithm that computes an output from an input signal, that is called software realization. Now, the message or the modulating signal, or that's also called the baseband signal. The signal which contains a message that is to be transmitted is called as a message signal. It is a baseband signal which has to undergo the process of modulation to get that transmitted. Hence, it is also called the modulating signal or the baseband or message signals. What is the next? Carrier signal. Carrier signal, that is the signal which is used to carry, as name is given, carrier signal, to that help to carry the message information or the modulating signal to the receiving end. So this is the high frequency signal which has a certain amplitude, frequency and phase, what contain no information, is called as a carrier signal. It is an empty signal and is used to carry the signal to the receiver after a modulation. Next one is called modulated signal. So the resultant signal after process of modulation is called as modulated signal. So here the carrier signal is modulated according to the message signal or the baseband signal, and that is called modulated signal. This signal is a combination of modulating signal or message signal and the carrier signal. Now, what is the modulator? Modulator is an entity that accepts input message signals and convert it to an electrical waveform which is suitable for the transmission over the communication channel or the medium. It can be effectively used to minimize the effect of channel noise by matching the channel characteristics with the transmitted signal. It also provides capability to multiplex many signals. Or depending on the frequency of carrier signal, carrier is either sinusoidal or pulsating on the base of the modulation, and again it is classified like continuous wave modulation or the pulse wave modulation. Continuous wave modulation is again categorized into amplitude modulation or angle modulation. Then thereafter, the angle modulation is also again categorized into frequency modulation and phase modulation. Here in continuous wave modulation, the carrier signal will be a continuous signal, and another one is called pulse modulation system. In pulse modulation system, the carrier will be a pulse or a rectangular wave, and again it is categorized into two: analog modulation and digital modulation. In pulse modulation, the analog modulation is again categorized into three categories: pulse amplitude modulation, pulse width modulation, or that is also called pulse duration modulation, and pulse position modulation. The digital modulation is again defined as pulse code modulation, or it is categorized by delta modulation. So here we will see one by one what is the continuous carrier wave modulation. As we discussed in continuous carrier wave modulation, the carrier will be a continuous carrier wave. So in continuous carrier wave modulation is a high frequency sine wave used as a carrier wave. This is further divided into amplitude and angle modulation. So what is the amplitude modulation? If the amplitude of high frequency carrier wave is varied in accordance with the instantaneous amplitude of the modulating signal, then such a technique is called as amplitude modulation, that we will see later on in detail. Another one is called angle modulation. If the angle of the carrier wave varies in accordance with the instantaneous value of the modulating signal, then such a technique is called angle modulation. In angle modulation, amplitude will remain constant, and in amplitude modulation, angle will remain constant, or phase will remain constant. So again, angle modulation is further categorized into two categories, or it is divided into frequency modulation and phase modulation. So in frequency modulation, the frequency of the carrier wave is varied in accordance with the instantaneous value of the modulating signal, and such a technique is called frequency modulation. In phase modulation, if the phase of the high frequency carrier wave is varied in accordance with the instantaneous value of modulating signal, then such a technique is called as phase modulation. Now we'll see pulse modulation. In pulse modulation, the carrier will be a pulse waveform, or it will be the rectangular wave that is used as a carrier. So pulse, again it is categorized into pulse amplitude modulation, pulse width modulation, and we have already seen. So pulse amplitude modulation. In pulse amplitude modulation, the carrier is a rectangular wave which changes in accordance with the instantaneous amplitude of the modulating signal. The duration or the width of the width and position of the modulating carrier will remain constant. Here only amplitude of the pulse or rectangular wave will vary in accordance with the message signal or input signal. Whereas in pulse duration modulation or in pulse width modulation, here the width will vary and amplitude will remain constant. So in this, the duration or width of the carrier or rectangular pulse changes in accordance with the instantaneous amplitude of the modulating signal. Here the amplitude of modulated carrier will remain constant. And another one is pulse position modulation. Here in pulse position, the position of the pulse will vary according to the message signal. Their amplitude and width of the pulse will remain constant. So next one is called pulse code modulation, or PCM. PCM is the digital modulation technique. This is the gateway between analog and digital modulation technique. Pulse code modulation is a more effective and reliable modulation technique over PM, PWM, or PPM. Now, the need of modulation. Baseband signals are not compatible for direct transmission on a longer distances. Therefore, its strength has to be increased by modulating with a high frequency carrier wave, which does not affect the parameters of the modulating signals, so that the again modulation is required. Or by the modulation, here the height of the antenna is again related to the wavelength, the transmitting signal, or wavelength is related to the frequency. So we can say that the height of the antenna is related to the frequency of the transmission. So by the modulation, we can reduce the height of the antenna for efficient radiation and reception. The antenna should have a height compatible to the quarter wavelength of the frequency used, so that the height of the antenna should be lambda by 4, where lambda is equal to c upon f, where c is the velocity of light or velocity of the electromagnetic wave. So if the frequency of the signal is, for example, we are taking 4 kilohertz, then the height of the antenna required, that will be 18.75 kilometer. That is not practicable. And if we modulate the message signal with a high frequency signal, suppose the carrier that is of the frequency of 4 megahertz, then if the frequency of the transmitted signal is 4 megahertz, then height of the antenna would be only 18.75 meter. That can be easily constructed. So here, if we increase the frequency of the signal, then we can reduce the height of the antenna. So this is the major advantage of the modulation. Next one, we can avoid the mixing of the signals. As we know, the voice signals of the human being, that is within the range of 20 hertz to 20 kilohertz, or that is around 300 hertz to 3.5 or 4 kilohertz. So if we send directly the message signal or this modulating signal directly, then that will be mixed up. So by using this modulation scheme, we can avoid the mixing of the signals. The transmission of the baseband signals from several stations operating over the same frequency range get mixed up. If we transmit directly without modulation, then it will be difficult to separate out the message signals at the receiver end. Therefore, modulation of different signal sources by the different carrier frequencies avoid the mixing of the signals. This is another major advantage of modulation. Now again, we can allow the multiplexing by the modulation. So it allows multiplexing of the signals. The modulation permits the multiplexing in that 2 or more signals can be transmitted simultaneously over the same channel by using different carrier frequency. Here it can be used in the telephone system, or this is also used in the FM system, or it is also used in the television, where we can see the different channels on a same television or on a same electronic device. So this is another major advantage of the modulation. Now next one, it also improves the quality of the reception. So at low frequency, radiation is poor and signal get highly attenuated. Therefore, the baseband signal can not be transmitted directly over a long distance. So the modulation effectively increases the frequency of the signal to be radiated, and thus increases the distance over which signal can be transmitted faithfully. Now next we come to the, again, what is the multiplexing? Multiplexing is the process of combining multiple signals into one signal shared over a single channel. As we already discussed, the example may be television. So the multiplexing was first developed in telephony, where number of signals were combined to send through a single cable. The reverse process that is done at the receiver is called demultiplexing. So the concept we can see here, this is only for the concept, that multiplexer is used as the n number of channel messages are transmitted and multiplex, then transmitted by a single channel. And at the receiver end, here we are using demux, that will be again separate out each channel. But we can again use either frequency division multiplexing or the time division multiplexing or multiplexer. Again, it is categorized into two categories, analog and digital. Then analog multiplexer can be used as a frequency division multiplexing, FDM, or the wavelength division multiplexing. And another one that is called digital multiplexer, that may be time division multiplexing. Now the time division multiplexing may be again two types. It may be synchronous or asynchronous. Again, we can see the concept of the multiplexing. That is, here we are using suppose three signals: signal 1, signal 2, signal 3. Signal 1 is transmitted at 30 kilohertz, and signal 2 transmitted at 40 kilohertz. Then signal 3 is transmitted at 50 kilohertz, and this is channel 1, channel 2, this one. And here in between we are using some guard band to separate out the channel or to reduce the interference. And here at the DMUX, that is just reverse of the multiplexer, that we can separate out signal 1, signal 2, and signal 3. Now here each sub channel, these are the channel 1, channel 2, channel 3, these are the sub channels. So the each sub channel is separated by an unused bandwidth that is called guard band. Guard band are used to prevent overlapping of the signals. A guard band is a narrow frequency range that separate out two signal frequencies. This ensures that simultaneously used communication channels do not experience the interference. Now next, what is the advantage? So advantage, it transmits the multiple signals simultaneously, and again in WebDM it does not need synchronization between transmitter and receiver, and that only the disadvantage is it required more bandwidth. Now next we come to the amplitude modulation system. In amplitude modulation, the amplitude of the carrier signal vary in accordance with the instantaneous amplitude of the modulating signal. This is called amplitude modulation. So here the frequency and phase of the modulated carrier will remain constant. So this is the just concept. Such as the message signal or modulating signal. This is the carrier, high frequency carrier. Both are applied to the amplitude modulator. Then this one is called the modulated signal that is to be transmitted. So here we will see in detail. This one is the message signal, or this is the analog message signal. Here again, analog carrier is used with a high frequency. So if the message signal is superimposed on the carrier signal, then this one will be the modulated signal that is to be transmitted. Here the frequency has been increased. Now the mathematical expression of the amplitude modulation system. Here the instantaneous value of the modulating signal, which is given by small Vm, or that is the sinusoidal or analog signal. So the message signal can be expressed as Vm sin omega mt, where V, capital Vm, that is the peak value or the maximum value of the message signal, and omega m is the angular frequency of message signal. Then the instantaneous value of carrier signal Vc, that is equal to capital Vc sin omega ct, where capital Vc, that is the peak value of the carrier signal, and omega c is the angular frequency of the carrier signal. Then the peak amplitude of the modulated signal, that will be equal to A equal to Vc plus Vm, and then the instantaneous value of modulated signal, which may be given as Vm equal to A sin omega ct, where A is the peak value of the modulated signal, and omega c, that is carrier frequency, and A is equal to Vc plus Vm, Vc plus small Vm of Vm is equal to this Vm sin omega mt sin omega ct. So Vc can be taken as common out, then Vm by Vc can consider as M, which may be known as modulation index. Then Vm is equal to Vc 1 plus M sin omega mt sin omega ct. Then again, it can be represented, or we know the trigonometric relation 2 sin x sin y is equal to cos x minus y minus cos x plus y. So Vam can be represented as Vc 1 plus M sin omega mt sin omega ct, or Vm can be represented as Vc sin omega ct plus M Vc sin omega ct sin omega mt, or it may be derived as Vm equal to Vc sin omega ct plus M Vc by 2 cos omega c minus omega mt minus M Vc by 2 cos omega c plus omega mt. So this is the expression of the amplitude modulated signal. Now here we'll see there are three terms. The first term represents sine omega ct only. So this is called the carrier, or we see sine omega ct, that is called carrier. So the carrier directly transmitted. And second term, that is mvc by 2 cos omega c minus omega mt. So omega c minus omega m. And third term is omega c plus omega m. So second term is called lower side band, and third term is called upper side band. That the frequency of lower side band is omega c minus omega m, or fc minus fm, and the frequency of upper side band, that is omega c plus omega m, or fc plus fm. So here we can see the frequency domain representation of a AM wave. Here this one is the carrier, this one is lower side band, this is called upper side band. So this is omega c is angular frequency of the carrier, then the peak amplitude of the lower side band, that is mbc by 2, and again the peak amplitude of the upper side band, that is mbc by 2, this one. So this is the lower side band, this is upper side band, and the total bandwidth of total bandwidth required for the amplitude modulation, that is equal to omega c plus omega m minus omega c minus omega m, that is called 2 omega m, or bandwidth that may be equal to 2 fm. So the bandwidth required for the amplitude modulated signal, that is twice of fm. This is in terms of the angular frequency, and this is in terms of the frequency. Then the required bandwidth is this one. Now next, this we already seen what is the VC, VM, or omega m, AM, FC, FM. Now the carrier wave, after being modulated, the level of modulation that the carrier wave undergoes is called as a modulation index, or depth of modulation, or it is defined as, or it is the ratio of the amplitude modulating signal to the amplitude of the carrier signal, and is given as m is equal to Vm by Vc. This is called the modulation index, or depth of modulation, that we have already seen. And the percentage of modulation, if we take the percentage of this one, Vm by Vc, then that is called percentage of the modulation index. So next, here we will see if the modulation index is less than 1, then the modulation is called under modulation. So if Vm by Vm is less than Vc, then m will equal to, or m is less than equal to less than 1, or the percentage modulation, that will be less than 100%, then the waveform will be like this. And this type of modulation is called under modulation. And if Vm is equal to Vc, then m will be equal to 1, because m is equal to Vm by Vc. It means modulation is 100%, and that is called perfect modulation, or that is called critical modulation. Next, if we consider Vm greater than 2 Vc, then m will be greater than 1, or the percentage modulation will be greater than 100%. It means modulation is over, and the signal gets distorted, or some information will be lost. And this type of modulation is called over modulation. Here we'll see there's some information is this is overlapping, so here some information will be lost. And another one is called m is equal to 0. If m is equal to 0, then there is no modulation. It means carrier signal will be directly transmitted to the receiver. Here we can derive the expression for the modulation index in terms of V max and V minimum. So this is the modulated signal. So here we'll see this one is called maximum value of the modulated signal, that is called V max, and this one is called minimum value of the modulated signal, that is called V minimum. Then Vm is the capital Vm, that is the peak value of the message signal or the modulating signal, and that will be equal to V max minus V minimum by 2. And Vc, that is the peak amplitude of the carrier, that will be equal to V max minus Vm, this one. And if we put the value of Vm, then Vc will be equal to V max minus V minimum by 2, or Vc will be equal to V max plus V minimum by 2. Hence, we know modulation index, that is equal to Vm by Vc, then m will be equal to V max minus V minimum upon V max plus V minimum. So this is the modulation index in terms of V max and V minimum, and we already seen m is equal to, that is Vm by Vc. Now here again we consider, or we will calculate the power. So consider the following equation of the amplitude modulation that we already seen, or we already described. So this is the expression or mathematical expression of the amplitude modulated signal. Here there are three terms. First term is simple carrier, another one is for lower sideband, and then upper sideband. So that the total power that will be equal to the carrier power plus upper sideband power and lower sideband power. So the total power that will equal to carrier power is equal to V carrier square by R plus V LSB square by R plus V upper sideband square by R. Now here V carrier square and the all voltages are in RMS value. So if it is converted into the peak value, then V carrier will be equal to PC by under root 2. Then PC will be equal to PC square by 2R. Here R is the resistance of the system or resistance of the antenna. Now the power of the lower sideband that is equal to again the power of the upper sideband, because the upper sideband and lower sideband that is same, the peak value is same, MBC by 2 or MBC by 2. Then the power of lower sideband or power of upper sideband that will be equal to MVC by 2 on under root 2 divided by R, or that is M square VC square by 8R, or it can be represented as M square by 4 into PC square by 2R. Here VC square by 2R, that is again PC. So it can be written as the total power, that is VC square by 2R plus M square VC square by 4 into 2R plus this one. Here VC square by 2R is called PC, or if it is taken out, then PT is equal to PC plus M square by 4 PC plus this one, or PT upon PC that is equal to 1 plus M square by 2. Here the total power that is again represented in terms of, or that total power can be calculated by the PC and M square. If we know the modulation index and we know the carrier power, then we can calculate the total power of the amplitude modulated signal. Now here, if we consider M is equal to 1, then total power or total transmitted power will be equal to 1.5 times the carrier power. So PT will be equal to 1.5 times PC. Now here the PC that is 1, then again the sideband power that is equal to 0.5 that is required. So the power required for transmitting an AM wave is 1.5 times the carrier power of the perfect modulation. So this is simple derivation of the amplitude modulation system.